Okay mga sangga, welcome back. I'm going to explain again this moment or the force couple system. So it's also related to moment, but it's a couple of forces, just like two pairs of forces acting perpendicularly with a certain distance. Okay, so for example here, so you have here a propeller. Here, the propeller is here. It's a twin screw ship which develop a speed thrust of 300 kilonewtons. So the value of this one is 300 kilonewton. Also the same here. This is also 300. Okay. Of course, there is a torque here developed for a moment. So if you have like this one is F, and the other one, so yeah, the other one is going here, also F. So your moment here, or the couple, your distance here, moment here is just F times 12. 12 is the distance. Okay, D. In other words, F times D. From here, going here. Okay, so now, of course, if you have this force, it will rotate going here, right? Because it's in clockwise direction. Okay? It keeps on rotating clockwise in direction. Now, to maneuver the ship, there should be one propeller is turning full speed ahead and the other full speed also in reverse. This is what I'm saying. So we need some force P, which will be to counteract the counterclockwise movement. Or to counteract this counterclockwise movement, there should be P here, which is generated by this small boat. Okay, also here, just a small p. In other words, you could create also a couple of like this p and p, and now this distance here is just 120 minus 50. Okay, you have just 120 minus 50 over here, which will give you 70. So you have here this distance is 70. Okay, so at a certain point in there's the center of gravity, or the center of the both, which we can equate here to make it equilibrium. The moment of that point is equal to zero. So in other words, we can just say the moment here is P times 70. So meaning you have here P times 70 is equal to this one, F, 300 times 12 meters. Okay, take note that our force here is in kilonewton. In other words, we can compute for P, which is 51.4 kilonewton. Okay, so as simple as that. The the challenge is only to understand how these forces are behaving in this kind of problem. Now, how about this one? So you have a commercial airliner with four jet, one, one, two, three, four. So each is producing 90 kilonewtons. So of course, the thrust here, that jet, keeps the airplane to move in this direction. Okay, but then suddenly uh, and one of the four jet engines stop, not working. So at number three, it doesn't generate a certain force. So there's no force here. So we're going to determine what will be the resultant of the three remaining engine thrust vectors. Take note that the resultant is just, you have 1, 2, 3. You just have 90 plus 90 plus 90, and that becomes 270 kilonewton. So we get the resultant. Okay. Now we are going to identify the location. So if there's a resultant here, obviously you have two forces here, you have one here. So resultant should be coming here, right? So we need to identify this distance, which is, let's say, x. Okay. So the resultant is just 270 multiplied by x, okay, is equal to these forces. So we can consider clockwise. So from here going here to the center, okay, 12 and 9 is 21. So this force is going there. We just have 90, it's clockwise, times 21 multiplied by 21. And have the force of 90 at number 2 is going here. So the distance is 12. So you have 90 plus 12. Or times 12, I should say. 90 times 12. Now, you have another force here from the top. It's anti-clockwise. So that becomes minus 90 times this distance here to the center here is equal to 21. So you have 21. Now, if you're going to use your calculator, you can just compute x is equal to 4 meters. Okay, so that's all for the couple force system. So if you have questions, you may just email me or drop in the comments comment section. Thank you.